Hi all, I'm going to go over the friction and forces in 2D quiz, especially in preparation for the test. Hopefully you can get some feedback and help you move forward if you missed any of the problems on the quiz. Okay, so hold on a second, I've got to change something. Okay, so the answers to all the true false were true. So the reason this is true is that 6 and 6 can add up to 12. That's not our answer. And 6, when they're in the opposite direction, can add up to 0. So how we figure this out is we ask ourselves, does 9 fall between these two extremes? And it does. So how I'd have to do it, you don't have to know this, but so a 6 and a 6 like that wouldn't add up to 12, wouldn't add up to 0, but in this case, this would be somewhat close to 9. So that's how you can reason that out. Number 2 is true because the normal force goes by the cosine of the angle, and if the angle increases, then cosine of the angle decreases. 3, most of you got this right, so that wasn't an issue. 3.5, a lot of people missed. The answer is true because ultimately the distance is inversely proportional to acceleration. So you just got to look at what does the acceleration depend on. Acceleration is F net over m. That's mu mg. That's the force of friction divided by m. So you see the masses cancel out. So that's why it doesn't matter. Okay, which will not increase? That's B. Wider has no effect on friction at all. That's surface area. Okay, 5, we did a great job with the force diagram. We just didn't necessarily completely follow through. And I think some of you kind of peter out when you're doing a derivation. And if you just follow through with things, it can work out. Basically, I want you to find a coefficient in terms of acceleration and the force we're applying. Too many of you made the mistake of just saying coefficient is the force of friction divided by the normal force. While that is a true statement, that's not what was asked. Okay, so what you're supposed to do is take the whole point of this is it's accelerating because F is bigger than F of F. So I might start with, and this is not the only way you could do it, F net is F minus FA. Excuse me, force of friction. FA minus force of friction. And off to the side, I might say, okay, the force of friction is mu times the normal force, and that's going to equal mu times mg. Okay? So now I got F net. I'm going to apply the second law. A is F net over m, so that's F of A. Yeah. Or just F. I don't know why I'm putting F of A there, because it was given as F. Minus the force of friction. Now I'm going to put in that minus mu mg all over m. There's the second law. So that's now all I have to do is solve for mu. So if I multiply both sides by the mass, this is ma, right? And then do a little algebra with this part. Long story short, mu equals F minus ma all over mg. And that's what we're looking for. It's in terms of F and A and the givens. By the way, the m's do not cancel on this. You can't cancel out the m's. That's a no-no algebraically. And some of you lost a half point because you did that. Okay, next problem is just looking at components. So you have a car where we're pulling this way with an Fx or a Tx and an Fy. Okay, so all I want you to do for part 1 is calculate Fx, which is F cos theta, which is around 500. I don't remember the number off the top of my head, but the point is that's greater than the 460. So yes, it will move forward. On the other problem, the next problem, what's the normal force? You can't just say it's equal to the weight because there is an upward tension right here. So what I'd say is so if I look at the forces here, there's a normal force, there is mg. So I could say that Fy plus Fn, those are the two upward forces, so I'm going to add them, have to equal the weight because it's balanced that way. So the normal force is equal to the weight, which you calculate separately, which is around 9,500, 9,400, whatever that is, minus the y component of the tension. And so somewhere you had to find a y component saying it's F times the sine of the angle. And I believe if you when you plug in the numbers, you get something like 300. Let me just take a look at the quiz I have. You get 356. And so when you plug in all the values here, you should get 8950 or something close to that. Okay, moving on. This one, you got a TA, or here's an X, and here is a Y, so you draw those components. This is also 30 degrees. Now we want, and then you're told that B is pulling that way. There is no vertical to B, and then of course there is FG. Some of you had normal force. There's no normal force. It's not sitting on the ground. Okay, so I want you to express the weight in terms of A. Well, we can see that the two verticals, so I can say TY equals FG, and TY is TA sine theta. So there's your answer in terms of the equation, and then you got to explain basically that the verticals balance. Same idea with D. In this one, TB is balanced by TX. So you'd say TB equals TX, but you can't stop there. You got to do it in terms of the actual A. And so what is TX? Well, that's TA times the cosine of the angle. And some of you didn't do this last step. Okay. Force diagram on the shoe. We have a normal force. We have friction. Some of you forgot the friction. And then you have a weight, FG. If you drew the weight components, that's fine. Okay. So what's the magnitude of the force trying to pull it down the ramp? That's FG parallel, which is simply mg sine of the angle. Put in the numbers, you get 4.2 newtons. What's the magnitude of friction? And some of you lost 2 points here because you made a mistake of saying, well, let's start off. So force of friction, and this is going to be static friction now. Okay, so I gave you two coefficients to make sure you use the proper one. You don't use both. You use static when it's sitting there, which is what is happening here, or you use kinetic if it's sliding. So anyway, I would say that's mu times the normal force, and I'd use 0.68 for my mu. But the normal force is not mg because it's not flat. You have to do a separate calculation that is mg cos theta, which is about 7.2 newtons. So that's what I put into here for the normal force. And I get 4.9 newtons. Then I ask, is the shoe going to move or not? Or will it slide down the ramp? Okay. And the answer is no. But some of you lost a half point because you said the force of friction is greater than the parallel force. That's not true. If it was greater, then it would have to accelerate upward the ramp. They're equal, okay? So if it's sitting there, they have to be equal. So what you calculated above is the maximum possible static. That doesn't mean you get the maximum in this situation. All right, last one was an experimental problem, and we really need to work on this. We did this lab. There's two criteria such that the applied force, which you are measuring directly, is the force of friction. First one, most of you got. We had to be at a constant velocity. Or you could say no acceleration. The other part is you got to pull horizontally. Because if you don't pull horizontally, then what you're reading on the spring scale isn't going to be the horizontal force, which you're assuming is the force of friction. All right, I accepted normal force, this was looking for. I accepted weight, full credit. If you put mass, you had to explain how you'd use it to find a normal force eventually. If you did that in part C, that's fine. Okay, so this is where a lot of you missed the problem. Many of you said find mu by just taking the ratio of this to this. Well, that's true. That's not best practices. This is a lab. So first of all, you should have multiple trials, okay, of different normal forces and the corresponding frictions. Second thing you should do is you should graph the force of friction versus this. And then the third thing, mu is the slope. Okay, you did a lab like that. That's how you use best experimental practice. You don't base it on one measurement. Okay, so if you have any questions, make sure you ask me.